this ASMR video in which we will be talking about earthquakes and volcanoes. The outside layer of the earth is broken up into giant pieces called tectonic plates. These plates move around due to currents deep inside the earth. While they move, bump together, overlap, and slide past each other, they are making new areas of ocean floor. They are building mountains, and they are causing earthquakes and creating volcanoes. Plates that are under oceans are much thinner and less dense than those under continents. Most earthquakes happen where tectonic plates rub against each other. The magnitude of an earthquake is a measure of the energy it releases. It can be measured using the Richter scale, where a difference of 1 point corresponds to 30-fold difference in energy. The intensity of an earthquake can be measured using the Mercalli intensity scale, which grades earthquakes from 1 to 12. Here we can see this Mercalli scale. When the earthquake grade is 1 to 2, people can hardly felt it. Only instrument can measure it. When it is 5 to 6, rocking motion can be felt by most people, and buildings tremble. 7 to 8 is a scale in which cracks appear in buildings. 9 to 11 is a scale where most buildings are destroyed, and scale of 12 is a situation where almost all buildings are destroyed. Earthquakes can occur anywhere in the world, most damaging ones usually happen near plate boundaries. There have been many powerful earthquakes in the last 100 years. The largest in Chile was strong enough to move rivers. It happened on May 22nd, 1960. And its magnitude was 9.5 Richter. The second strongest earthquake was in 1964 in Alaska. On December 26 of 2004 in northern Sumatra happened a very strong earthquake, the third strongest in the last 100 years. Also in Japan on March 11 of 2011, very strong earthquake happened. A volcano occurs where molten rock called magma erupts up from under Earth's surface. An exploding volcano is one of the most dangerous sights on our planet. Volcanoes often form near the boundaries between tectonic plates, but they can also form elsewhere. There are about 550 active volcanoes on land, and more of them under the sea. Hot molten rock that flows across the ground is called lava. It keeps the name lava even after it has cooled down and solidified into rock. When volcanoes erupt, they can create tall columns of ash. The height of these columns varies depending on the amount of energy in the eruption and how much magma is thrown out. Here I have a picture in which we can see how high this column can be. The highest column can be 31 miles or 50 volcanoes can erupt with massive force. The most explosive and violent type of eruption is called Plinian. In Plinian eruption, a powerful stream of gas and magma is blasted into the air. Then we have Volcanian, Strombolian, with small ash cloud, Hawaiian with no ash cloud, and the weakest type of eruption is called Icelandic, and these eruptions are quiet without loud explosions. A couple of words about tectonic plates. Tectonic plates are made of Earth's crust together with the top layer of the mantle. These plates move slowly but constantly, and the movement between them create earthquakes and volcanoes. Most tectonic plates carry both oceans and continents, but few of them are almost entirely oceanic. Where plates are pushed together, dramatic changes to the landscape can occur. If both edges are continental, a huge mountain range will form in the collision zone. Here we can see on these pictures 30 Earth plates. The largest one is Pacific plate. Then we have North American, Eurasian, two African plates, Nubian and Somalian. Antarctic plate, Australian plate, and South American. They are the largest, but also Nazca plate Here we have mid-Atlantic ridge. Most of this range lies about 2,500 meters or 8,200 feet underwater. And Iceland on the north is the only part of mid-Atlantic ridge that is above sea level. The Eurasian plate is continental plate. 85% is land and only 15% is water. Interesting plate is Mariana. Here is the Challenger Deep, the deepest known point of Earth at 35,800 feet below sea level. It is 10,911 meters. $55 million years ago, the Indian and Asian plates crashed together, creating the Himalayas. Molten rock erupts from an opening on Earth's surface. Volcanoes develop. That molten rock called magma is formed in the places deep in Earth's crust. Or even in the mantle. When magma reaches the surface, then we call it lava. Volcanoes are classified as active, dormant, or extinct, based on how often they erupt. An active volcano is one that is known to have erupted in the recent history. A volcano that has not erupted recently, but might erupt again, is dormant. And the volcano that has stopped erupting is extinct. Some small volcanoes erupt just once, while a large volcano can erupt thousands and thousands of times over its can see Crater Lake. Rainwater can fill all the volcanic craters and make this kind of lake. Here we can see so-called fissures. It is a crack that sometimes leaks lava. Here we can see a big ash cloud which eventually fall to the ground. Pyroclastic flow is a fast, dangerous flow of hot gas, ash and rocks. Small hole through which magma escapes is called secondary vent, and main vent is the site of most of a volcano's eruptions. Here we can see a geyser. It is a jet of water driven into the sky. Often we can see these geysers in Iceland. Here we can see magma chamber. Magma collects under the active volcano, sometimes over an area many miles wide. In an average year, approximately 60 volcanoes erupt. As we said before, Earth's outer shell is made up of tectonic plates. These plates are constantly moving and push past each other with hard, jerky movements. As this happens, energy is released in the form of powerful shock waves causing an earthquake. When an earthquake happens under the seafloor, it can create a tsunami. Many types of events can cause tsunamis, including volcanic eruptions near the sea or in the sea. Landslide into the oceans also can create tsunamis, and even asteroid impacts. However, the most common cause is a huge earthquake under the seafloor, usually where the edge of one tectonic plate rises above another. Here we can see how this tsunami is caused by an earthquake. First, we have sea floor rupture. A large rupture below the sea floor causes an earthquake. At the same time, a huge block of seabed is suddenly thrust upward. It shuts up several feet. This in turn pushes the seawater above, triggering a tsunami wave at the ocean surface. At the sea surface, the sudden upthrust of a mass of water from below sets off a series of high energy waves. They start traveling over the sea surface at a speed of over 500 miles per hour or 800 kilometers per hour. Waves spread out in opposite directions from a line in the sea surface, roughly parallel to the rupture line on the seafloor. In the open ocean, each wave has a low amplitude or low height and may even pass unnoticed. Tsunami waves out at sea are evenly spaced a distance of up to 120 miles or 200 kilometers. When a tsunami wave approaches a shore, it slows down and its height increases. The upward sloping seabed creates a resistance to the water movement, and it pushes the water so that the wave is amplified and gets bigger. Here we can see how sea becomes shallower. And here we can see when tsunami waves are approaching a shore that they create a crest of wave. The top of a large tsunami wave usually foams as it approaches the shore. Sometimes water is drawn away from the shore in a few minutes before a tsunami wave arrives. We call it a sea drawback. When a tsunami wave hits a shore, it doesn't usually break and collapse. Instead, it continues to surge forward for a considerable distance, flooding the whole coast. The powerful rush of water can smash buildings. The strong 2004 Indian Ocean tsunami has been caused by a rupture under the seafloor that was 1,000 miles in length. Some countries are more affected by earthquakes than others because they sit on the boundaries between tectonic plates. Here we can see the 10 countries with most earthquake fatalities: Peru, Haiti, Italy, Turkey, Iran, Pakistan, India, Indonesia, China, and Japan. In California, it is also possible that a big earthquake happen. In Southern California, every day 30 small earthquakes occur. During the very large earthquakes, the whole planet Earth vibrates back and forth in space. This vibration can be 1 centimeter or 0.3 inches. With this, we will conclude today's session. Good night.